We can finally state the structural lemma known as the cut property. This is a lemma from which we'll derive the correctness of our MST algorithms. So the lemma considers an undirected graph G. So let's consider the graph that we've been having as our running example. Now we're going to take a subset of edges. I've marked a particular subset of edges in this graph by the green edges here. Now we're going to assume that this subset of edges is part of an MST T. Now you should think of this set X as you have an algorithm for the MST problem, and you have a partial solution that you're building up edge by edge. X is your partial solution so far. And you assume by induction that this partial solution is correct so far. So, to be correct so far, that means that this subset X that you've constructed so far is the subset of a MST T. Now you don't know what T is, but you know that your solution is correct so far, so it is a subset of some MST T. So for this particular example, I have the green edges, which I've marked here, and these are what my algorithm has constructed so far. And we're assuming that our partial solution, X, the green edges, are part of an MST T, which I marked by red edges here. So the red edges are an MST T, and we don't know this MST, but we have the green edges, and we just know by induction that the green edges are part of an MST. So we have a partial solution which is correct so far. And our algorithm is working edge by edge. So we're going to consider the next edge that we're going to add into X, and we want to prove correctness of this next edge being added into X. Now what are we going to assume about the edge that we're trying to add into X? We're going to assume that it crosses a cut of this graph. So in particular, we're going to take a subset S, and we're going to look at the cut between S and S bar. So here's a particular set S, and here's the complement of S. Our assumption is that no edge of our partial solution so far, X, crosses this cut, S bar. So notice that no green edge crosses between S and S bar. Now notice there are many sets S where this is true, but we get to choose any set S where no green edge crosses between S and S bar. Now there are no green edges crossing between S and S bar, but there's at least one edge of the graph G which crosses from S to S bar because it's a connected graph. So we're going to look at all edges of the graph G which cross the cut S bar. So I've marked in pink or purple the 5 edges of the graph G which cross between S and S bar. Now of these 5 edges, I want to take a minimum weight edge. So let E star be a minimum weight edge. Now there might be multiple edges of minimum weight. Doesn't matter, you get to choose which one you want. So let E star be any minimum weight edge across this cut. So let's mark this particular edge as E star. So we're assuming that these 4 other edges crossing the cut have weight which is at least the weight of E star. Now finally, what's our conclusion? Our conclusion is that we can add E star to our current MST construction and we'll still be on our way to an MST. So if we look at our partial solution X and we add E star to it, so we look at X union E star, then this is a subset of T prime where T prime is an MST. So if our partial solution X was on its way to an MST T, we didn't know T, but we just knew that it was correct so far, then if we add an edge, which is the minimum weight edge across a cut, and no edge of the partial solution crosses this cut so far, then if we add this edge E star to our partial solution, then we'll still be on our way to an MST T prime. Now this MST that we're going towards now, it might be different than the previous MST, but our goal is just to find a MST. We're not looking for a particular MST. So if we were on our way to an MST before, so our partial solution was correct so far, then we'll be on our way to an MST by adding this edge E star in.